Hello everyone, and welcome to our webinar today on SIEM, or Security, Information, and Event Management for ZOS. If you have any questions, please send them to us in your chat box because we will be doing a Q&A session at the end. You can also email them to us at info@sdsusa.com. Here's our agenda for the next 50 minutes or so. We'll give you a brief overview of our company, review a recent survey conducted by Bob Thomas and the Enterprise Systems Media team, and Stu Henderson will be providing us insights into a mainframer's guide to SIEM. Our own Colin Vandeross will be providing more information on SIEM for ZOS. And then, of course, as I mentioned, we'll have a Q&A at the end. Well, SDS, or Software Diversified Services, celebrated our 33rd year this year, providing mainframe software solutions to the market. Our headquarters is located in Minneapolis, with the bulk of our support and development team right down the halls from one another. SDS has strived to bring solutions to the marketplace that provide both cost savings while still using elegant and state-of-the-art functionality. Over the years, we've developed more solutions for the distributed environment, we've added to our mainframe portfolio, and we've partnered with key strategic subject matter experts for excellent software solutions. I'm pleased to introduce our guest speakers for our webinar today. Bob Thomas is the CEO and founder of Enterprise Systems Media, Inc. He brings a wealth of experience of IT solutions and knowing customers' interests and needs. Stu Henderson is CEO of the Henderson Group and is a well-known consultant who specializes in computer security for IBM mainframes, Unix, and Windows. Colin Vandeross is our Senior SE here at SDS with over 25 years as a customer and several years as a systems engineer. He'll be providing more information on SIEM for ZOS. And I'm Deb Hodson, National Sales Manager with 30-plus years in IT, having been at IBM, Candle, HP, and now SDS for the past 6 years. I'll be your moderator today. I'm now going to hand it over to Bob Thomas to summarize a recent ESM survey on SIEM. Bob?
Thank you for inviting me as guest speaker to present some of the 2014 Security, Information, and Event Management, or SIEM, survey findings. Today, I'll be presenting some of the key data points and insights we gained from this survey as they relate to the use of SIEM. The survey respondents were spread across a good cross-section of various organizational roles. Those respondents who selected other included roles such as Chief Security Architect, Chief Information Security Architect, ID Auditor, Security Manager, and other similar roles. We asked all respondents if their company has a SIEM solution in place. As you can see, 86 respondents, or 61%, said yes, while 25, or 18%, said no, and 30, or 21%, didn't know if they had a SIEM solution in place or not. If respondents answered yes to the previous question, we asked them to indicate which computing platforms were included in the SIEM solution. Respondents could only pick one of the above listed platform descriptions. As you can see, 54, or 61%, said their distributed system, Windows, Linux, Unix, or Solaris, platforms were included in their SIEM solution, while 27, or 31%, said both their distributed and mainframe systems were included in their SIEM solution. No respondent said that only their mainframe ZOS system was included in their SIEM solution. All the companies that were surveyed have at least one mainframe, all are Fortune 500 size companies, and all are located in the U.S. Respondents that selected distributed system, or Windows, Linux, Unix, or Solaris, were then asked to indicate which group in their company is pushing to have SIEM. As you can see, security management was the most selected group by a wide margin. While the right folks within the organization are pushing for SIEM, they don't have the mainframe included in their SIEM solution, or they don't know that the mainframe is included. Not knowing if the mainframe is part of the SIEM solution is as bad as not having the mainframe included in a SIEM solution, because it shows that there is a lack of coordinated effort for SIEM within the company across all platforms. Stu Henderson will talk more about the importance of a well-coordinated, multi-platform SIEM effort in his presentation today. When a respondent selected distributed system, Windows, Linux, Unix, or Solaris, to indicate which computing platforms were included in their SIEM solution, we asked them to rank a set of SIEM solution requirements for their company from most important to least important. This table shows that the number one ranking item was collecting, correlating, and reporting security events, with the next two requirements almost tying for second most important requirement. The least important requirement to those respondents was the multi-platform SIEM solution that included the ZOS mainframe. If a respondent selected both distributed and mainframe systems to indicate which computing platforms were included in their SIEM solution, we asked them to confirm that the ZOS mainframe was included in their SIEM strategy. The confirmation was a clear yes. So we asked the respondents who selected both distributed and mainframe systems how they currently monitor their ZOS security events. 12, or 44%, of these respondents stated they use both IDS and SAF SMF security reports, while 8, or 22%, indicated they use only SAF SMF security reports. We asked these same respondents who had selected both distributed and mainframe systems if there is a formal project in place for SIEM. 20, or 74%, said yes, while 3, or 11%, said no, and 4, or 15%, indicated that they didn't know. Finally, we asked these same folks who selected both distributed and mainframe systems to rank the same set of SIEM solution requirements presented to those who had indicated their SIEM solution included only distributed system, Windows, Linux, Unix, Solaris, in their SIEM solution. These two tables show the SIEM requirements rankings for those respondents who selected distributed system, Windows, Linux, Unix, Solaris, to show the systems included in their SIEM solution versus respondents who selected both distributed and mainframe systems. While the four requirements were ranked differently, the ranking of the SIEM solution requirement, multi-platform SIEM including ZOS mainframe, Windows, Unix, Linux, etc., was ranked exactly the same in both cases. The difference is that the respondents who selected distributed system, Windows, Linux, Unix, Solaris, did not include the company's mainframe in their SIEM solution, while those respondents who selected both distributed and mainframe systems did include the company's mainframe in their SIEM solution. As I mentioned earlier, Stu will now talk more about the importance of SIEM and also some of the missed opportunities when it comes to monitoring security events on the mainframe.
Thanks, Bob. Very interesting results from your survey, and we really appreciate you reviewing those with us. I think Stu will help enlighten us now on a mainframer's perspective and what to be cognizant of for SIEM. Stu?
Thanks, Deb. I'd like to talk to mainframers about security information and event management, or SIEM. This is an extremely valuable tool that we often don't use as much as we might on mainframe computers. We're going to show you what SIEM is. We're going to show you how it can be used. We're going to show you how it applies to mainframes and why an enterprise-wide view of the whole situation is worthwhile. Here's our agenda. We'll start by answering the question, what is SIEM? We'll talk about what you can do with it, and we'll talk about isolation, because there's a tremendous missed opportunity for mainframers involving isolation of SIEM data. We'll talk about that, and we'll talk about mainframes and the enterprise, how this all relates to SIEM. We'll give you some recommendations. We'll wrap it up with a summary and a call to action. And as we're going through this, you'll see that one issue is going to be your creativity or imagination, because SIEM is one place where you have an opportunity to be creative, to be imaginative, to come up with new ideas that serve practical purposes. So what is SIEM? Security information and event management is the logging, the collection, the analysis, the presentation of security-related log information on a computer or computers, as we'll be seeing. And if you want to remember what the acronym stands for, SIEM, the S and the M are easy to remember. The S is security and M is management. That's why we're all here. The I and the E are different, though. The I is for information. That is overall information processing, whatever you'd want to do to analyze or present the information. But the E stands for event, because sometimes there will be a specific event and we don't want a day-old trend report. We want immediate, real-time response to certain events. So we're going to have overall information processing. We're also going to have event management. How are we going to respond to the critical things that need immediate attention? You'll see that there are a variety of audiences, and each audience will have its own purpose. Some of these are only tangentially related to security, and one of them you'll see actually may not be directly related to security at all, but it's something that is worth keeping in mind. So just one other issue here is the whole idea of purposes, because you need to keep in mind the purposes of what you're trying to do. It's real easy with this sort of stuff when you try to get creative to get sidetracked and come up with something that looks really cool or seems really interesting, but if it doesn't serve a practical business purpose, maybe you don't want to invest a whole lot of time in it. So here are some of the audiences we might be providing SIEM for, and I won't read these to you, but you can see the last one, the marketing department, probably is not directly security related, but there are things that we can do for the marketing department, and if we're processing all of this information, yes, the S in SIEM stands for security, but let's not limit ourselves if we can help our organization do better. So let's talk about what you can do with SIEM. Imagine that you had information for one Unix or Windows computer. You could log information about every single event there. We're going to take this as our starting point because, as you saw from Bob's survey, most of the SIEM activity that we see is in the distributed world. Now imagine further that you could format, analyze, present all of this information about this one computer any way that you wanted to. What sort of things would you want to do there? There are three major questions to think about as you ask yourself, what are you going to do with all of this log data? First, what data do you want to select? What data elements or fields do you want to include in any given analysis or presentation? Second, how do you want to analyze it? How do you want to present it? And third, again, we're going to say this over and over again, keep in mind, what is your purpose here? Why are you selecting this data? Why are you presenting it or analyzing it the way you are? If you don't have the purpose in mind, you may end up spinning your wheels, so use that as a star to guide us and keep us on track. Well, as you would with any reporting project, and SIEM is a form of reporting project, your starting point is going to be to list all the measurements, all the data elements that are available to you. You'll want to include time. There'll be timestamps. You might want to represent it as time of day or day of week or day of the month, or there are lots of possibilities there. And if you have more than one computer involved, you'll need to make sure that either you synchronize the clocks on the computers or you adjust for any differences in the clock settings if you're not able to synchronize them. So once you list the measurements like this, take two or more of the measurements and say, how can I map them? There are many ways to map them. How can I map these two data elements to achieve some goal. And this is your chance to be creative. When we talk about 2 or more, if you want to include more than 2 measurements in your analysis, one way to do this is to take 2 of the data elements and make a ratio of them. And then map, again, there are several ways to do the mapping, map the ratio against some other data element, of course, keeping your purpose in mind. But this is where you can come up with things that no one has ever thought of before. Your analysis might identify, for example, trends, or even more interesting, changes in trends. And one of the things we found here is that if change occurs very, very gradually, you're not aware of it, you tend to think of it as normal. And you may know the story about the frog. If you throw a frog into a pot of boiling water, he'll jump out. If you put a frog in a pot of room temperature water and very slowly bring it to a boil, you'll have dead frog. The same thing happens to us instead of the water gradually getting cooler. For example, the number of password resets we are experiencing in our data center, if it increases very, very gradually over time, we will sit there and think each week it's normal because this is sort of like last week, sort of like last month, and we can reach a point where we are spending outrageous amounts of energy and perhaps exposing ourselves to security risks because of the large number of password resets, but we think it's normal because we got there very gradually. You may have seen audit reports recommending that the security administrator should review the violations report every day. I've never seen a case where that made any difference in anything. But if you plot the number of violations over time so that you can see how often they're happening, see the trend, see if there is a change in the trend. Think about the slope of the line in calculus, if that helps you. That can be much more useful information and can help us identify things that we're starting to assume are normal, but really they're outrageous. And too many times we put up with things that are outrageous because we arrived at them gradually and we weren't aware that they were becoming outrageous. In contrast to gradual changes over time, your analysis might identify spikes, sudden increases. For example, an increase or a sudden spike in the number of invalid passwords might indicate someone is trying to guess his way into your system. Your analysis might identify top 10 lists. I've had to eat my words on this one. I, at one time, was responsible for performance tuning for a new computer system. And my boss asked me to produce him a list of the top 10 programs by CPU usage, by number of IOs, and by several other elements. I produced the report for him, but the whole time I was producing it, I was saying to myself, thank goodness to myself, well, this is a total waste of time. What could we possibly learn from this? I could probably predict what these top 10 are going to be. And I was surprised. I was very pleasantly surprised. I learned some things that, several of which led to useful changes we could make to tune the system. But I was surprised and learned things that I would not have known if I had not produced the top 10 lists. This leads us to my catchword for SIEM. And my catchword is, surprise is good. Surprise is good. If you're doing a lot of data collection and reporting and nothing shows up, it's really boring and you're not learning anything new, then maybe nothing's happening on your system, or maybe something's happening but you're not identifying it because you're looking at the wrong stuff, or you're looking at the right stuff in the wrong way. If you get surprised by the results of your SIEM, that's when you're getting the benefit from it. If you learn something that's going on that you didn't realize was going on, that's when you get the benefit from SIEM. Surprise is good. Which leads us to the next thing you might identify, which is unusual events. And sometimes you look at stuff and say, that can't be, the measurement has to be wrong, and you start looking at the underlying factors and what is actually going on, and you discover there was something very unusual, and you're very glad you learned it because you need to address it. You might identify changes in frequency patterns, or you might find ratios exceeding some limit, and you could have confidence limits, or you could have exception limits. That's a excuse me, that's a nice way to reduce the amount of paperwork and the amount of attention you have to pay if all you're getting is notification of the exceptions. So suppose you could do all this, and suppose you're a security administrator. Would you want to know about a change in the number of invalid passwords, or a change in the number of password resets? Would you want to know this by day of week, by department, by subnet? Would you want to know about all of the invalid passwords or a count of the invalid passwords inside your firewall, treated separately from the invalid passwords that are coming from outside your firewall? Would you want to know if there were an enormous increase in the volume of data being downloaded with FTP from your data center, maybe hundreds of times more than usual, or maybe hundreds of times larger than your largest file? I think we could all name a movie company that might have benefited if they had been aware that this was happening in their installation. So would you want to know if there was a change in the weekly number of access violations against production files? Would you want to know if that number were anything greater than 0? Would you want to know, is there a change in the ratio, here we do the ratios again, of invoices received to the payments, the number of payments made from accounts payable? Stop and think for a moment what that ratio might be indicating to you, if the ratio is changing. And here's an example of how you might take two things that individually might not be important to you, but a change in their ratio might be of great interest to the fraud department. Would you want to know about the trend of orders received, the count of number of orders received mapped against the new advertising campaign's timeline? And again, you can see the possibilities for creativity here. You could almost start your project by listing all the data elements, and then for each one, list all of the other elements you could map it against, and scratch your head and say, well, what could I do with this? And then think about ratios in the same way. So suppose you're a security administrator. Would you want to know anytime someone used the fire call emergency ID, or any use of a privileged ID, or any delays in processing that might represent a denial of service attack? And just to lay the groundwork, because I know you know where I'm going with this, if you're the mainframe security administrator, would you want to know about the use of privileged IDs or delays in processing on the distributed platforms that provide the demilitarized zone between your mainframe and the internet? Tying this information together will have an effect on the organization. It will have the effect very often of integrating, or at least improving, communication between the security administrators on the mainframe and the security administrators on the distributed platforms, and that will be a good thing. Well, what can you do with SIEM? How would you like it presented? It might be an exception list. It could be a top 10 list. I've learned that the hard way. It could be a graph over time. It could be a ratio over time with limits flagged in red. And again, those limits could be confidence limits or exception limits. Maybe you could present the data as a pie chart. I think that's more useful for presentation than it is for analysis, but I'm not going to say there's no point to it because I've learned my lesson the hard way. Sometimes you want a real-time alert. We've talked about this already. There's some events where what you want is an immediate email or phone call or something to get immediate action taken. Or you might present it as some frequency or ratio plotted against time of day, or you might even get all of the information presented as a management dashboard where all the information would be available at your fingertips. Well, smart data centers use SIEM on their distributed platforms. Bob has shown us from this survey that mainframes are often left out of this analysis. And this means the mainframe SIEM information is in an idle data silo, and you can't get the benefit of combining it with the SIEM information from the distributed platforms. Anytime you take information from two different data sources and integrate the information, first you can come up potentially with new measurements, new ratios. Second, because you have two different data sources, you have an opportunity to compare or contrast information from the two sources, and sometimes the differences between them will be more interesting than either one of them by itself. But this isolation of the SIEM data on the mainframe says it's also not being used at the enterprise level. That is, when we say enterprise, we mean the combination of mainframes, distributed platforms like Unix and Windows, and the internet. If you tie these all together, and they are tied all together, if you try the SIEM administration of these all together, this is where you get the real benefits. These benefits expand tremendously when you combine the mainframe SIEM data with the distributed SIEM data. And as we said earlier, this can also lead to integration or communication between the different security administrators. We have a cliche here. It's very, very common to have a mainframe computer where most of the data and often most of the processing is done, and you have something like maybe PeopleSoft running on a Unix or Windows computer connected to the mainframe and facing the internet. And all of the processing, all the requests that come in to the Unix or Windows computers, there may be some processing maybe by PeopleSoft on the distributed server, but when it needs information or it needs hard processing, the distributed platform turns to the mainframe, maybe to DB2 or CICS or MQ series or something else, to get the data and the processing that it needs. This is a very common situation, and it often happens that the distributed administration is isolated from the mainframe administration. If you take the mainframe SIEM data and the distributed SIEM data, and you say, we've got a split here, we've got information from two different sources, you can combine these or contrast them with each other. For example, you might look at the number of transactions of a given type that originate inside the firewall against the number of transactions of some perhaps other type from outside the firewall. Again, having the split between mainframe and distributed SIEM information would make it possible for you to compare the number of internet probes. This is hackers trying to collect information in planning an attack on your data center. The number of internet probes against the number of internet probes that actually reach the mainframe. That could be a measurement of how good your demilitarized zone and your firewalls are working for you. Again, if we split the data and recognize two different sources and then put them together, We can recognize new ratios. For example, we could count the number of distributed PeopleSoft transactions against a count of the selects or updates in DB2, or against a count of the mainframe CICS transactions. We have another factor, though. When we talk about isolation, within mainframes, the information is very often siloed just within the mainframe. For example, the chief SMF and RMF data is very often processed separately from the CICS, DB2, or MQ logs. And again, USS, Unix on the mainframe, often has its own syslog, which is treated separately. TCP/IP, which relies on USS, has its own syslog. And in many cases, each of the TCP/IP daemons, for example, FTP or email, these daemons can have their own syslogs. When we say syslog in uppercase, we're talking about the file that has a record of every message on the operator's console. VTAM can have its own monitoring and logging, and I'm sure that there are other sources of information, and while these are all on the mainframe, they are often treated separately and not integrated to take advantage of what you can get from combining from the different sources. So imagine you took all of these different mainframe data sources and tied them or integrated them with the distributed SIM data relating to the Unix and Windows computers between your mainframe and the internet. Tremendous increase in the analysis that you can do. Well, to wrap this all up, there is a wealth of information at our fingertips. There's more data than we know what to do with. The smart people are going to be the ones who recognize that it's there, figure out how to use it intelligently. But this means doing some thinking, doing some analysis, and some creativity, starting by recognizing what data is available from all sources and asking, what could I do if I could pull this all together? Whoever shows us how to benefit from this is going to be a hero in our organization. If you're going to be the one to do this, and I hope you will, you need to start by finding out what are the possible audiences. Don't forget the marketing department. Don't forget the fraud department. Don't forget internal audit. We're talking about security, but there's lots of other benefits we can get here. You need to identify the computers and the networks and all of the data sources available to you, and you need to identify the tools you have to do the analysis and presentation and perhaps the integration of the data. When you're selecting software to help you with the integration and analysis and presentation of the data, there's some basic steps you follow for software acquisition of any kind. You start, of course, by defining your requirements, and then you list all the possible software tools that could help you meet these. And you do a formal analysis of these tools against your requirements. Probably throw in a cost factor as well there. The next step is, I think, the most important one on this slide, and it's very often the one that is most often ignored. Ask the vendor for the names and phone numbers of 3 satisfied customers. Phone them, buy them lunch. Ask them what they like about the product. Ask what they don't like about the product. You'll learn a tremendous amount. And of course, nowadays, you'd be missing an opportunity if you don't check social media to see more about people's experiences and online reviews and reactions to various software products. Tremendous opportunity here. In many organizations, it's not being addressed at all. If you don't address it, and I hope it'll be you, but if it's not you, then who will do this for your organization? Well, if you'd like some more information, here we've got some sources, and we can make a copy of this handout available to those who are interested. I'm going to turn this back to Deb now and say thank you all for your kind attention, and Deb, back to you. Thanks.
Thanks, Stu. Clearly, there are important factors and considerations for our audience as they look at the mainframe as part of the overall SIEM solution. We'll now look to Colin for additional details and considerations for the mainframe and SIEM. Colin?
Thank you, Deb, and welcome to everyone. Thank you for your time. As you saw in today's survey results, it appears that there are a lot of ZOS customers that are not exploiting SIEM in their environments. We know that enterprise-wide monitoring of security events is critical, not only for tracking malicious activity, but also to meet compliance requirements. Most organizations have a wide range of security packages tracking everything from antivirus update and intrusion detection alerts to Unix and Windows event logs. Surprisingly though, many corporations, the most critical processor and repository for corporate data is overlooked, and that is the mainframe. The fact that you can report on events in real time is a reason for customers to start taking a serious look at incorporating ZOS systems into their SIEM strategy. An enterprise SIEM can collect and aggregate data and events from heterogeneous sources. So Unix, Linux, Windows, in fact some agents provide APIs so that you can get events from applications into your enterprise SIEM. There may be important information that you want reported or logged to your SIEM. What about those hundreds of routers spread across your network and also the network switches? There is a wealth of information on these hardware devices. Are you securing the logs or the commands that your network folks are implementing on a daily basis? You can also send information from other syslog devices to your enterprise SIEM. And the great thing about this is it's all in one central location. It makes the searching of logs so much easier when you have a SIEM or using the SIEM to interrogate your logs. You can find the exact time that an event occurred and also the corresponding security event. All of the questions that may need to be answered during an audit or a violation, like who, what IP address, when did it occur, and what was the location. These are answers that you can have at your fingertips all in one place. I remember quite often when I was involved in task forces and my very first point of reference would always be the log to see what occurred. The logs do not hide anything and they contain all of the bare facts. Sometimes though, depending on which product you were using, it would have a primary and a secondary log, and when the primary log would fill up, it would automatically switch to that secondary log. If there was information in that secondary log, it would be really difficult for me to try and ascertain what the cause was of that problem because the data was overwritten already in that secondary log. You can configure rules for specific conditions. So if the event comes up on the log, you can certainly email the security team, or if you like, generate an SNMP trap to an SNMP receiver. Thresholds can be configured, so anytime a threshold is exceeded or even underutilized, you can set off the alarm bells. Conditions, violations, anomalies can all be monitored, and scripts can be kicked off in response to these events. The retention of historical data is very important, especially if you need to go back for an extended period of time, and also for compliance requirements. There are laws in place that dictate how long customer data should be retained, especially in the financial industry. One thing of enterprise SIEMs is that once the logs are retained, they cannot be altered with. So in fact, they are tamper-proof. No one can delete or hide information in these logs, which is an excellent security feature on the enterprise SIEM. With a SIEM in place, you can improve your application, delivery and performance. There is no more waiting for data or reports to be run the next day. In fact, in conversation with our customers are always striving to do more with less. And also the reality is that the security team sometimes may not have the manpower and also the expertise to keep up with all of the attacks. You have to use the technology available to get more from less. And using a SIM in ZOS will allow customers to embrace technology and run leaner and meaner shops. Here is a diagram that illustrates some of the different sources that can feed information into your centralized SIM. So the mainframe is included, the Windows servers, Linux, Unix servers, network devices like routers and switches, applications, databases, DASD, and also security devices. The logs from these heterogeneous devices, so the Windows and Unix systems, are all stored in one central location. Then to break it down even further, here are some of the applications that you can monitor and send events to your SIM specifically for System Z. The SMF records are one of the primary ways that you can monitor events on System Z. Messages and write-to-operator messages can also be sent to the SIM. You can monitor events that occur on TSO, CICS, IMS, DB2, TCP/IP, FTP, and also ZOS USS. As can be seen, the entire spectrum of the mainframe can be monitored to ensure that nothing is overlooked. So what does a SIM agent do for you if you do implement one on ZOS? Well, firstly, it improves the efficacy of RACF, ACF2 and Top Secret, and the SMF and console messages. They are true real-time monitors and they deliver mainframe alerts immediately to your SIM event manager. It makes use of intelligent data mining from several different sources like the messages written to the console and also SMF events to capture the events. They can also track DB2 audited events to provide an additional level of mainframe security. One thing to be sure of is once you implement a SIM on ZOS, they incorporate pretty easily into your existing enterprise security monitor. So regardless of what you may be using on your distributed side for monitoring of your SIM events, you will find that when you implement your ZOS agent, it'll integrate pretty seamlessly into your enterprise security monitor. So this is a typical process today. You'd find that the security administrator will run reports from yesterday using the SMF data and then produce reports that give them insight to what occurred yesterday. They will review these reports and identify what action needs further investigation and then maybe follow up with the offending parties. I used to work for a large bank and I remember getting these emails from the security team a few days later when I tried to do something that was not in the scope of my authority, like perhaps updating PalmLab. Most times when receiving these emails, and because it came a few days later, trying to remember the reason for my action proved to be pretty challenging. As you can see, it is not the most proactive way of monitoring an enterprise. However, when you install a SIM agent on ZOS, the monitoring is in real time and there is immediate notification of the event via email, or you can certainly telephone the party if it is something that is really important. The immediate response and quick turnaround of problem resolution makes for a very proactive environment. When you go about in implementing SIM on ZOS, you would go install an agent on all of the LPAs that you require visibility. You would set up the monitoring events that you want monitored, so you would edit your PalmLab and enable the relevant SMF events. In fact, some solutions are pretty nifty. They come with a nice baseline where they advise you what events are critical or what they deem critical to monitor. And then there are even some solutions where perhaps the relevant SMF record is not enabled. They can still gather information on that item if the product deems it very critical. You need to filter the events and make sure that you are monitoring the correct events. So to make sure that your enterprise SIM is configured correctly, you would have to go through this process. You do not want the opposite, where there are too many events reported and no one pays any attention to them. and you have to make sure that you're monitoring the events that are important to your organization. You may be familiar with the separation of duties, also known as the segregation of duties concept, which is a concept of having more than one person required to complete a task. In business, the separation by sharing of more than one individual in one single task is an internal control intended to prevent fraud and error. So that's why you need to include some of the teams, perhaps your security team, the ZOS team, maybe your network folks, the storage folks, and also the performance team, and you get together and decide what are the critical events that need to be monitored on ZOS. I've extracted a few samples. Here you can see a few console messages that I thought would be of interest to report on. This is a vendor environment, so it's not as busy as the customer environment. But I always remember the dreaded ICH 408I message, the one that says I have insufficient access to a resource. What about those user IDs that are revoked, or perhaps even the FTP logon failures? Here, for example, you can see there's a user ID BSFM2. There was a logon attempt requested for it. All of these were attempts within sub-second of each other, and that could be a sign of some potential unauthorized behavior. Do you have an idea what files are being transferred to and from your mainframe? Perhaps you want to keep tabs on that. Perhaps there are files that contain sensitive information that you want to prohibit access to, or just at least monitor them. And here are a few examples on some of those FTP transmissions. Here are some console messages that would be of concern. Like I said to you, this is a vendor environment, and these are samples, and they may not necessarily apply to your site. Then to break it down even further, you can monitor events, and like I said to you, you would enable the SMF records that need to be generated. You would edit your SMF member in PalmLab. And for example, you could monitor the deletion of datasets, or perhaps the renaming of datasets. That may be pretty important for you to get a heads up on what folks are doing. Perhaps when jobs terminate, a batch job or a TSO, or even a starter task. Maybe if a TSO user is logging on in the middle of the night from an unfamiliar IP address, that could be a point of concern. And then also you could monitor TSO logons and logoffs, and also the updates to vSAM files. Then maybe monitoring what your security folks are doing on RACF, Top Secret, and ACF2. Perhaps the delete group or the delete user, or even the setar ops are functions that you want to be made aware of, or commands that you want to be made of when folks are using them. Do you know what's happening in your OMVS environment and also on DB2? The ZOS SIEM agent will certainly be able to report on these events. You can monitor events on syslog-D. Coming from a network background, they are pretty powerful operands or definitions that you can enable in your TCP/IP profile. Are you aware of them? Should they be enabled? Those are all questions that you need to ask of your team when you sit down and decide what events you want to monitor. Perhaps you want to monitor VTAM, or also APPC events. Like I said to you, there are some agents that allow APIs, so you can get access to some of the applications. Then Unix events. What about directory searches, the change audit command, and the very powerful change ownership commands? Those are all perhaps commands that you want to keep tabs on. Okay, so I've given you an idea on how SIEM can be incorporated into your ZOS environment. Let me wrap up the session. Before I wrap up the session, I'm going to hand it back to Deb, but let's go over the summary of some of the items we covered today. We found that SIEM, according to some of the survey results, is widely implemented on the distributed environment, but perhaps not so much on ZOS. Perhaps it's time for customers to take a very serious look on some of the events that they want reported on ZOS. Companies can leverage the SIEM agents on ZOS to report on these critical events. More importantly, the logs can be retained from these different sources, and you can customize these events to alert on real events. So the minute something important happens on your network or on ZOS, you can alert the relevant folks to take the appropriate actions. Most of the ZOS agents can incorporate into your existing SIEM strategy. So if you have one already on your distributed environment, you're going to find that if you do implement one on ZOS, it's pretty simple to incorporate into that strategy. It makes for proactive monitoring. You're no longer that reactive, waiting for reports the next day before you can take certain actions on. Immediately as events occur on ZOS or on your network, your TCP/IP network, you're going to be made aware of them. And lastly, can you risk not knowing what is occurring in your ZOS environment? Thank you everyone for your time. I'm going to hand it back to Deb to field some of those questions that came in. So thanks everyone, and we look forward to hearing from you.